Hi, my name's Hamza Elhamdadi, and I'll be presenting our work, Vistrust, a multidimensional framework and empirical study of trust in data visualizations. This work was done as a collaboration between Harvard University, UMass Amherst, and University of Toronto. If you saw a visualization like this while you were browsing your preferred news source, how likely would you be to trust it? And perhaps more importantly, how did you decide whether to trust it? Did you trust it because it was clear and easy to read? Did you think it looked professional? Or maybe you're just a trusting person. I ask these questions because there are many reasons why someone might trust someone or something. And when we're interested in measuring trust, we have to think about all the possible factors that might influence that trust judgment. Now, this isn't new. A lot of social science research already considers the multiple factors that influence trust. We refer to these factors as trust antecedents. One example of a trust antecedent is benevolence, which is when you decide to trust a person because of their goodwill. In other words, you believe that they are generally ethical. It's easy to consider how these antecedents occur in human-to-human situations. However, when we apply this way of thinking about trust in a human-to-non-human situation, take for example a person viewing a visualization, we are met with a challenge. The social cues we normally use to assess trust in human-to-human situations are no longer present. Instead, they're replaced by visual cues from the visualization. When our data visualization community has tried to measure trust in the past, we often relied only on a single item Likert scale, something like, on a scale from 1 to 7, how much do you trust this visualization? But like we mentioned, this question doesn't really get at how you make your trust decision. Also, you might even have a hard time defining what trust means in this context. To address the problems of using a single item, we propose a multidimensional approach that uses several different antecedents of trust, building on the social science research we mentioned earlier. This approach is the main contribution of our work. We created a framework that describes specific antecedents of trust in visualizations and offers guidance on how to measure them. Our framework separates the antecedents by whether they are linked to visual encoding, like visual clarity, or aspects of the data itself, like where the data is sourced from. Our framework also separates them into cognitive and affective trust antecedents. Cognitive antecedents include the clarity of a visualization and the underlying data, how accurate the underlying data is and how transparently and precisely it is represented in the visualization, how complete and comprehensive the underlying data is, how easy to use the visualization is, and finally, how up-to-date the information is. Affective antecedents include cues from the visualizations and data that impact the emotions of viewers, as well as the apparent ethics of the data collectors and visualization creators. It's also important to consider how individual characteristics, such as whether you are a trusting person, can influence how a person decides whether to trust. And finally, a person's assessment of trust will influence their behavior, which we can subsequently measure, either through questions of self-reported behavioral intentions, as we do in this study, or through longitudinal studies that track actual behavioral change. In addition to proposing this theoretical framework, we apply the framework to a case study which investigates the effects of visual complexity, data topic, and chart type on participants' trust in visualizations. We used a between subjects design where each participant was shown one visualization with either simple, moderate, or complex visual complexity. To ensure the results didn't just apply to a single type of visualization, we created line charts and bar charts with the 3 levels of visual complexity. The dataset we used to create these visualizations tracked the weekly count of COVID cases in vaccinated and unvaccinated people across different age groups. To control for the effect that the topic of the visualization dataset can have on trust, we generated a separate set of visualizations with the same data, but labeled them as if the data tracked the weekly count of crop diseases in Croatia, caused by different types of insects and fungi. To do this, we updated the chart title, categories, y-axis label, and data source, but we kept the visualized data the same to avoid any confounding effects of different datasets. To generate the questions we used in the study, we took the trust antecedents from our framework and created questions and scale items for participants to answer. These items captured cognitive and affective dimensions of both trust in the visualization and trust in the underlying data. To run the study, we used a crowdsourcing platform called Prolific, on which we recruited 600 participants, approximately 50 for each of the 12 combinations of independent variables. The study itself was implemented on the survey platform Qualtrics. Participants were first given a guided tour through the components of the visualization, and then asked to explore for 15 seconds. Once they had finished exploring, they were asked to rate their agreement with the trust antecedents. After collecting the data, we analyzed it using 2 linear regression models. Our first model predicted trust in the visualization, and our second model predicted trust in the data. We gave both models the predictors complexity, data topic, and chart type, and we included all of their interactions. And finally, both models were given the participants' demographics and individual characteristics as factors to account for their impact. We found some really interesting implications about how people form their opinions of trust. In general, participants trusted visualizations that were clearer and easy to understand. In other words, they trusted simple visualizations more than complex ones. In fact, participants agreed with the statement, "I find it easy to understand this visualization more for simple visualizations than for complex ones." And when asked to rate the visualization on a scale from unclear to clear, they rated simpler visualizations as more clear. Participants' qualitative responses to the simple visualizations included, "The visualization is easy to understand and gather info from, and I trust that the information provided is accurate." And, "I think it's really easy to follow, and it appears to be realistic information that could potentially happen." Another key finding was that participants generally rated the line charts as more aesthetically pleasing than the bar charts. The qualitative responses for the line charts echo this sentiment. For example, one participant wrote, "The different colored lines made it easy for me to figure out the data between the different age groups of vaccinated and unvaccinated people." And another said, "It looks like a graph that has reliable information on it." A line graph is used often. We also found that participants trust the underlying data more as the complexity of the visualization decreases. In other words, people found the data of simple visualizations to be less biased and more trustworthy than that of complex ones. One qualitative response to the simple line chart said, "Everything is displayed cleanly. There is no evident bias." We'd like to wrap up by considering some ways we can extend this work in future research. One avenue for future work could be to include both positive and negative items in our scale for each trust antecedent. An example of a negative item would be, "I find this visualization difficult to understand." Also, we included only 2 behavioral measures in our study, and these were self-reported. In the future, we could capture behavioral changes in a longitudinal study to better understand how participants' assessments of trust impact their behavior. And finally, trust is harder to establish when visualization viewers are in a negative affective state. So applying our framework with visualizations that actively elicit negative emotions can help discern how visualizations can establish trust in difficult contexts. Ultimately, our framework provides guidance on how to measure trust in data visualization more comprehensively. We provide a theoretical framework that covers several antecedents of both cognitive and affective trust in visualizations and the underlying data. And importantly, we don't have to ask participants to do the hard work of defining trust for themselves. This is the first step towards a richer understanding of how visualizations can foster trust or hinder it. Thank you for watching our video, and we hope you enjoy the paper.